Hello and welcome to Thinkermaker. I'm Dr. Parag Shah. I've been working in the front line of hospitals in the fight against COVID. I'm a member of the British Society for Immunology and I have no links with pharmaceutical companies. Now, we pick up from the last episode to see which brand uses which vaccine making method. Valneva and also the Chinese company Sinovac are making weakened virus vaccines using method 1. It's old and well known, but there is a recognised small risk that the weakened virus becomes strong again, and that can get nasty. And our immunology textbook tells us that weakened viruses are less effective at creating immunity compared to live viruses. This vaccine is 50% effective and it does utilise fetal cells in the production process. But to be clear, those cells don't end up in the vaccine. The next method was to make a harmless protein that looks like the virus. The Canadian company Medicago is using the protein making ability of plants to do this by using protein building blocks, a bit like Lego, one block at a time, quite tricky, and make it resemble COVID with spikes to fool immune cells. And no fetal cells involved, but it does need an adjuvant ingredient. So they can't actually claim it's vegan, but close. It's still being developed and tested. The third method of making a protein vaccine is used by GSK, Sanofi and also Novavax. They artificially make and inject a part or all of the spike protein. Again, the spike protein is constructed using building blocks, then either the whole or just the tip of the spike is injected. GSK Sanofi does not use fetal cells in their COVID vaccine process. Their vaccine is 62% effective and it does use that adjuvant AS03 containing the ingredient squalene, so it's not vegan friendly. In contrast, Novavax's 89% effective vaccine uses a different adjuvant called saponin made from the soapbark tree. So it's close to being a vegan vaccine. Novavax also does not involve fetal cells. Instead, it uses insect cells from a moth to manufacture vaccine. Now, let's explore the genetic technology methods to create immunity. First, the DNA vaccines. This type is being made by Johnson & Johnson as well as AstraZeneca with Oxford University. Their efficacy is about the same, around 70%. And for many, the big difference between these two is that the AstraZeneca Oxford vaccine does use fetal cells to mass produce the carrier virus for lots of shots. Whereas the Johnson & Johnson vaccine uses insect cells instead of fetal cells to mass produce. Apart from that, these DNA vaccines work pretty much the same way. So what happens after that carrier virus containing DNA is injected? Well, first, it cuts its way into a human cell like COVID does. And once inside, it wants to get its payload of engineered DNA into the nucleus, which contains human DNA. Here it is close up. See the human DNA? That DNA provides the normal human code for the normal human cell protein factory to make normal human proteins. The vaccine's carrier virus is designed to open up and sneak the engineered DNA, see it, into the human cell nucleus. There it is. And then that engineered DNA code is converted into mRNA code for COVID spike. The mRNA is exported out of the nucleus and it heads for the human cell protein making factory where the conveyor belt of workers are building human proteins. Then the mRNA sneaks in and changes the worker's instructions to make COVID's spike protein instead. Now, there are two risks associated with DNA vaccines. One, that engineered DNA could integrate and alter the natural human genetic code. And 2, the carrier virus can become aggressive. These are not anti-vaxxer scares, as our textbook tells us. Page 361. Let's read. There is a possibility the nucleic acid, that's the engineered DNA, might be incorporated into the host genome, that's your genes, or become virulent again. Now this is Moderna's investor brochure, and it also highlights DNA vaccine risks on page 2. Read, once inside the nucleus, DNA vaccines have a risk of permanently changing a person's DNA. And this 2021 scientific article is an update on COVID vaccines and also says it. Paragraph 3.6, DNA vaccines. Let's read. There is a potential safety risk of integration into the host genome. That's almost word for word from the textbook. Check out the link. So, the textbook said it, Moderna said it, and an up-to-date science journal said it too. Yet, the BBC reality check says it's false. Well, they haven't cared to distinguish one vaccine from another. But if they are talking about the AstraZeneca Oxford or the Johnson & Johnson vaccines, they are wrong. How can that be a reality check? Or is the BBC biased? Okay, now, let's put the spotlight on Pfizer and Moderna's mRNA immunisation, including its downsides, and why it truly is still very experimental. First, let's look at what that globule of high-tech petroleum fat is for. One jab contains millions of them, so let's look inside. There they are, floating around inside of you. Some of them eventually make their way to a human cell. Now remember blowing bubbles when you were a kid? Remember how 2 bubbles would touch and instead of bursting they'd sometimes merge into one, like this? Well, because the globule is greasy and so is the outer boundary of the cell, they kind of act like bubbles. The mRNA globule merges into the cell and gets pinched off like a bubble inside the cell. Eventually the pinched off bubble pops to release the mRNA into the cell, and it then makes its way to the protein factory, where the conveyor belt workers are dutifully making human proteins. Now when it gets there, it gives its new message to the workers to stop making human protein and start making lots of COVID virus spike proteins. They fill the cell and then come out of it to end up circulating around our bodies. Now, a previous episode showed how immune cells recognize COVID by its spikes. Well, instead, immune cells learn to spot these self-made spikes and makes antibodies against them. And because it's the same shape as the real COVID spike, if COVID appears in future, antibodies are already there to catch the virus. All very clever. On the plus side, mRNA vaccines do not involve fetal cells or contain any virus. But now let's explore some negatives about mRNA. What happens to it after enough spikes are made? Where does it end up? But first, why does mRNA need this globule for protection? Well, because science papers tell us that RNA is fragile, and that limits its usefulness. Check the link. Here, a professor is being frank about it. RNA is very fragile. There is an RNA strand. It's like a length of rope frayed at both ends. Now, a rope like that unravels itself easily. And like that, one reason RNA is so unstable is that it easily falls apart. And that's no good if it must travel from injection through the skin to be transported to a cell, then across its boundary into the cell. If RNA is injected naked, then inside the body it degrades too quickly to reach the cell. Now, how do you stop that? Well, how do we stop frayed rope from unravelling? By adding tape wound around the ends. And that's what mRNA vaccine makers do. They strengthen the RNA by adding molecules to its ends which act like a tape scaffold to make it less degradable. Now, I'm sorry, but I must include this bit of techie detail for the fact checkers. That molecular tape is called a poly-A tail, and the longer that tail, the more stable is RNA against degradation. The Encyclopedia of Systems Biology, Science Direct, and the famous Max Planck Institute, they all say this. Check them out. Nature Journal says it too. The poly-A tail makes for RNA stability. There's the address. So you see, it's synthetic mRNA, and scientists modify it even more to exaggerate the code so that those protein factory workers are guaranteed to get the spike making message. So to summarize, we have RNA made naturally in our body like that. Science journals tell us that natural RNA is constantly broken down by proteins floating around the body like this. But scientists want no chance of that happening to their spike making message, which is why they made a synthetic RNA with exaggerated code and reinforced ends to avoid breakdown on its way to the protein factory. And they make it even more strong, stable and less degradable by wrapping it in a petroleum fat globule. The fancy name for this is lipid nanoparticle, and lipid means fat. So synthetic RNA travels through the body protected from breakdown. And you're going to hear a lot about this fat globule over the coming years because investors hope to make billions with it by using it in a whole set of medicines and vaccines. There's a lot of money in this game, but mRNA jabs do come with unknown risks and they're still experimental. The next episode will cover that. By now, I hope you feel empowered to gauge which vaccines match your ethics and values. In the next section, we'll explore risks associated with vaccines, which option might best match your risk profile. Thank you for watching.